In Thomas Aquinas' eyes, the natural world was fundamentally teleological. That is, he held that everything and every process has a telos, a final cause, an end or a goal. It seems easy to identify final causes in our own actions. The goal of buying a sandwich is that I'm hungry and I want to eat it. But do we really want to attribute such final causes to all natural things? Do simple inanimate things like rocks have goals? From a modern perspective, teleology and final causes are problematic and were consistently and explicitly rejected by the earliest thinkers in modern science. No modern physics textbook mentions final causes or teleology. So has it really been relegated to the dustbin of history? Aristotle defined the final cause as the end or that for the sake of which, and the idea is often linked to words like goal or purpose. Again, the idea of a final cause is most obvious in our own actions. If I want to become a physicist, I know that I need to get a PhD in physics, which means I need to get into grad school, which means I need to do well on my calculus exam, which means I need to drink this cup of coffee to stay awake and study. We can think and plan how to achieve complex goals and set about carrying out the plan. Even when we do not succeed, we know what our goals were, and they give reason to why we acted the way we did in the first place. While animals may not have goals as complicated as getting a PhD, we can see a final cause in a cat chasing after a mouse in order to have lunch. In a lesser sense, we can talk about plants having final causes or goals as well. An apple tree produces apple seeds in order to make a new apple tree, which itself makes apple seeds and so on. Complex biological processes help bring about such development and reproduction, and aspects of teleology can be seen in many of these processes. Once we get below living things, though, the idea of a goal seems even more problematic. What is the goal of a rock, or a lake, or a bubble of air? Aristotle clearly believed inanimate things had final causes. For instance, he talks about the final cause of burning to be to create more fire, and the natural place that Earth moves towards is the center of the universe, while fire moves towards the extremity of the heavenly spheres. If we try to think of these as goals, though, we naturally slip into thinking, whose goal? The hunk of Earth's? The fire's? Is there something in the piece of Earth that desires to be at the center of the universe? Or is the center of the universe somehow acting on the rock? It all seems quite mysterious and unscientific. If we recall his definition, though, Aristotle did not begin with a notion of goal, but simply the idea of an end, as in the end of motion, a state of rest and stability. At its root, Aristotle is not asking what do rocks or trees or dogs want to do, but rather, where do they usually end up? What do they tend to do? Rocks tend to fall through the air and sink in water. Water falls through the air but collects in puddles and lakes. Air bubbles up through water into the atmosphere. These inanimate ends do not need some external actor or some internal consciousness or intention to make sense of them. It's just what rocks and water and air tend to do. This stripped down notion of final causality as the end of motion, the stable state that a natural thing tends towards, is not so mysterious to modern science. In fact, it is the foundation of everything we do in modern science. Modern science is, in fact, built on the presupposition of final causality in nature, so much so that we don't even think to ask about it. Imagine an electron. It has certain properties like mass and charge. What does an electron tend to do? It primarily tends to be attracted to positively charged objects and repelled by negatively charged ones. When it is placed around a bunch of other charged particles, it tends to draw close to positively charged protons or ions, and if it is not moving too quickly, it will become bound as part of an atom. But not bound in an atom in any random way. There are consistent patterns for how the electrons organize themselves in atoms, which lead to the patterns and organization of the periodic table we are so familiar with. A physicist would not use final causality to describe what is going on here, but would talk about the electromagnetic force and the minimization of energy in the atomic orbitals that the electron is bound in. Nevertheless, if electrons were sometimes repelled by positive charges and attracted to negative charges, we would have no way to distinguish positive and negative charges in the first place. And if electrons ended up bound to random particles at random energies, they would not organize into a nice periodic table of elements. Chemistry would be a chaotic mess. Someone might object, in this chaotic world, it would be impossible to study any natural phenomena. And I would absolutely agree. But the point is that, philosophically, we cannot take this orderliness for granted. And a fundamental part of that order is final causality. There is no one part or aspect of physics or chemistry that encapsulates final causality. But if we open our eyes to this broader notion, we will find it everywhere. In the ability of water to dissolve salt but not oil, in the complicated shapes that protein molecules fold into, and in that particular pattern of particles that we expect to result when a Higgs boson is produced by smashing protons together at the Large Hadron Collider. The strictures that things like the law of conservation of energy and momentum or the second law of thermodynamics puts on all natural processes speaks of the common threads in the tendencies or final causes of all physical things. We do not need to correct our science by inserting statements about final causality. But neither should we presume that it is a concept that is somehow anathema to modern science. As Aristotle and St. Thomas believed, final causality is a fundamental feature of the natural world, present at every level in various ways. They tended to use it more explicitly in their descriptions of natural processes than we do today, but the type of final causality that they were looking for in nature has not been expunged from modern science. It has been absorbed into the very practice of science and the confidence we place in it. For readings, podcasts, and more videos like this, go to Aquinas101.com. While you're there, be sure to sign up for one of our free video courses on Aquinas. And don't forget to like and share with your friends, because it matters what you think.